common misconception that the human impact on the atmospheric carbon dioxide concentration started with the large-scale burning of coal, oil, and gas. Actually, humans started to influence the environment thousands of years ago when we cleared forest for agricultural land. Clearing forest releases CO2 to the atmosphere when trees and other vegetation is burned or decays. Now we see this increase in atmospheric CO2 from early deforestation in the ice cores records from Greenland and Antarctica, and it starts already prior to the fossil fuel era. But however, the ice core records also reveal that this increase in CO2 has not been continuous over time. In the last millennium, there's some conspicuous time periods during which CO2 goes down. And these time periods coincide with major historic events. There have been large wars and epidemics. In particular, there have been two long-lasting events, namely the Mongol invasion in China and the conquest of the Americas. And there have been shorter events, namely the Black Death in Europe and the fall of the Ming dynasty after Manchu attacks in China. It has been hypothesized that these wars and epidemics are the reason for the CO2 drops we see in ice cores. Because when a substantial fraction of the regional population is killed, then agricultural land is abandoned and forests can regrow. The regrowing forest would then take up CO2 from the atmosphere and store it, getting down the atmospheric CO2 concentration. Now, I wanted to see how much of an effect these historic events in the last millennium actually had on climate. And I performed a climate model study together with Christian Reick and Martin Claussen at the Max Planck Institute for Meteorology and with Ken Caldeira at the Carnegie Institution. We applied a detailed reconstruction of historical agricultural land to a climate model that can simulate the CO2 exchange between vegetation and the atmosphere, but also tracks the CO2 through the atmosphere into the ocean. And running such a coupled climate model over a millennium timescale is something that has not been done before. In these simulations, we find that there is indeed substantial uptake in regrowing trees. The strongest event in this respect is the Mongol invasion. During this, about 700 million tons of carbon have been taken up in regrowing trees. That's an amount equivalent to today's annual demand for gasoline. But despite such substantial carbon storage in above-ground biomass, we find that none of these events could have caused the drops in ice core CO2. We identified three reasons for this. The first is, although regrowing trees may take up carbon dioxide, there's still substantial CO2 emissions from the soil. Prior to the historic events, when farmers cleared forests, there was always dead plant material left on the ground or in the soil, which decays over decades and centuries. A second reason is that trees just take a long time to fully regrow. And in particular, during the short events, the Black Death in Europe and the fall of the Ming dynasty, there was not enough time for the forest to reach its full carbon potential. A third reason is that the rest of the world was not affected by the war and epidemic, so even if a substantial decrease in the regional population occurred, the global population still continued to grow and to clear forest and therefore cause substantial CO2 emissions. We find that only the Mongol invasion and the CO2 uptake during that event overwhelmed the concurrent CO2 emissions from elsewhere in the world. So overall, we find that it's possible that the Mongol invasion caused a temporary attenuation of the CO2 increase from global deforestation, but we cannot explain the CO2 drops seen in ice cores by these historic events. To explain those, we will have to turn to other climate forcings, in particular changes in solar activity, volcanic eruptions, or natural climate variability. Today, agricultural land is being abandoned, in particular in North America and Europe, simply for economic reasons, and partly forest is allowed to regrow. Investigating the reasons behind earlier CO2 drops, as we did for our ice core records, will help us understand what the effect of land cover change in the future and today will be.